Hello, everybody. Sorry, we double clicked on the video clip there. Ooh, look at it. How are you, Sergey? Welcome, Sergey. Welcome, everyone, to another Percona meetup on our regular live stream. Sergey, how are you doing?
Yep, doing great, doing great. How are you, Matt?
Good. Thank you for stopping by. We always love to have you come out and chat with us. And let's see. Oh,
Yeah,
look, we even
it's,
have
it's
some.
my pleasure. Always glad to come.
Vinny says that he loves you. By the way, he
Yeah,
so
I know. We wrote a book together, so it's like a
yes,
marriage.
yes. You wrote a book. How did that process look?
Oh, well, it looked like a lot of self-reflection, self-criticism, disappointment in your own powers. But then it came to fruition, and now it's a great book. So yeah, but it's not about PostgreSQL, unfortunately.
It isn't. It isn't. But it is about MySQL, right? And
Yes, right.
so, we're going. For those who are here for the Postgres content, we will get there in a second. But Sergey did write a really interesting book on MySQL with Vinny, and it's worthwhile mentioning if you haven't gone out and seen that. Take a look at Learning MySQL, and let me see. I can pull it up. It is available everywhere books are, and I'm gonna do this. This is like an infomercial or a quick plug for the book, right? So let
Yeah.
me go ahead and I'm just going to throw this up on my screen just so we can see. So if you're interested in learning MySQL, check it out. Look at that. It's on Amazon, and it's available everywhere books are sold. So, and look at that. It's even got a 5-star rating. So, check it out. Support our local folks. And look at that. Gonzalo's here just for the elephant hats. Um,
I have a plush elephant toy, but I
do
don't
you?
have a
Where is your
kind of.
plush elephant toy? You should get it.
Let me just grab it.
Yes. So for Gonzalo, we're gonna grab the plush elephant toy. Um,
It's seen better days. Yeah, getting a bit worn out, but it is here.
oh, and what is
Keep
that
it
from? It's from Postgres. What
PG Day. PG Day Russia 16, right?
16? Oh, 2016. Wow, that's
Yeah,
some time ago.
that's kind of old elephant. Yeah, I can go to school.
Ah, well, so if you haven't seen the book, like I said, check out Sergey's book. But we're here to talk about Postgres. And Sergey, for you, Postgres is something that is near and dear to your heart. Obviously, you were participating in the Postgres community back in 2016, so 5 years ago.
Yeah, yeah. I was doing Postgres before coming to Percona, where I picked up MySQL, which all led to me writing a book about learning MySQL because I was learning MySQL just not a long time ago. But before that, I was doing PostgreSQL, and yet before that, I was doing Oracle. So, for a lot of us open source folks, I started with Oracle in around 2010, and then in 2015, I went to become a new field at the time, the DevOps engineer. But I retained my kind of DBA specialty, and I picked up the databases and I looked after them. And those were PostgreSQL databases. And yeah, then I had to learn PostgreSQL the hard way. So I was an Oracle engineer a week ago, and I became a PostgreSQL DBA, a week after I joined. So yeah.
What version of Postgres was that, by the way?
That was 9.2, I think, when I joined, and I left at 9.5.
Okay. So I remember way back in the day. Right? Like I actually wrote a couple video games, like web-based games, and I came from an Oracle background as well, and I used MySQL and Postgres, and I kind of switched between them a couple times early in the days, and that was my first kind of experience with Postgres. And the thing that always stuck with me was having to vacuum. And it was such a foreign concept to me coming from Oracle, right? Because as an Oracle DBA, let's be honest, um, having to vacuum your database, you're like, what is that? What's that about? Um, And it makes sense once you understand it. But you wanted to talk today a little bit about vacuuming, auto vacuuming specifically.
Yeah.
But
Well,
maybe fill in those who are listening who don't understand what a vacuum is, and we'll start there.
yeah. Well, yeah. As for you, for me, the whole idea behind this stuff was really foreign and really unexpected. Like, for instance, MySQL is much closer to Oracle and how it deals with the MVCC stuff. But to come to the vacuum and to the auto vacuum, I guess we should start with a bit more fundamentals and with the MVCC model or the multi-view concurrency, right? Because the vacuum is a direct consequence of how PostgreSQL organizes its data in a way that multiple queries can read multiple row versions, right? So this whole thing is about that. And the thing is that unlike many other databases, PostgreSQL doesn't have an undo, doesn't utilize any form of undo, and it just stores row versions right there in the table. And that for me was quite kind of surprising when I started working with PostgreSQL, right? So
and just so for people listening, basically what that means is, you go to, let's say you have a row, and that row has, your name and address, and someone in the system is updating your address to a new address. In a lot of other databases, what they'll do is they'll keep the original address information, the changes, in an undo space that will eventually get cleaned up. Postgres keeps your old address and new addresses in the same physical location, right, Sergey? That's what you're saying,
right? Exactly, right. They specifically, if you have free space in the block, it will just in the page, it will store the next new row version in the page, right? And to do so, there is a whole machinery for storing this. Like you have to account for the transaction that inserted the row, the transaction that deleted the row, or like updated the row, because the update in PostgreSQL is just delete and insert consequently for the data model. And what happens with the row that you do, like when you say my address was changed, right? So I had address A, you updated it or somebody updated it, and now it's address B. But there are actually two records. In the data file, there are going to be two records for me. So why do we need that? And how do we deal with them, right? So we need that because we all like our databases, modern databases, relational databases, for how they allow us to write queries, and kind of expect that if you run a query, you will get results for the time the query started. Or even more, with a repeatable read, you can expect the whole transaction to be consistent, right? So for that, you actually need those dead rows, because maybe a transaction started before you updated my address. It will see my old address. The new transaction that started after you committed, it will see the new address. So for a while, two addresses are completely valid. So this is the whole basis and the whole foundation for the vacuuming, for auto vacuuming, and for the whole machinery for those actions. So now we have two row versions. Eventually, my original address will never be seen by anybody. We will come back to that in a while, but there will be no transactions that started before you updated my address, right? So nobody needs it. And that's when the vacuum comes, because we have basically an unused row. Nobody will ever read it. Nobody needs it. So what do? We could rewrite just the full table, just take the consistent the data that is actually required and write it down, but that's expensive. So PostgreSQL, quite a long time ago, actually don't remember when, I was there when I found it, introduced the concept of vacuum. And the vacuum, and the auto vacuum, which we will come to, is the process that goes ahead and removes those versions. And it actually does quite a bit more than that. But yeah, the gist of it is basically garbage collection. So
yeah.
while the data, so for maybe developer folks who work with languages that do have garbage collection, it is kind of like garbage collection. You have an object that has no references. nobody can ever access it. It's just there. It sits on the heap, right? So it's dead.
Yeah, and I think that's, it's a good explainer for that, because I think the concepts there make sense once you hear them out, but when you hear like the process of vacuuming, it's like, oh, well, wait, why? And the fact of the matter is that process is really required. Otherwise, the database starts to fill up with those dead, inaccessible rows. And, it starts to cause bloat. And not only does it cause larger amounts of data storage, it also slows down queries and it slows down other activities, because you actually have to search through even the ones that are not available.
Yeah, and it also has an effect on your indexes, because indexes are not versioned in the same way. And you, in a simple terms, you can think about the indexes in PostgreSQL as having references to every row version. So when you traverse an index, when you come to a leaf page, you, without going to the table and reading every row version and checking it against your current view of the transaction, your snapshot, you cannot know whether the row that you read is going to be available for you or not. And that, unfortunately, eliminates the index-only scan optimization, right? So the one we love, where we just store a bunch of data in the index and we never really need to touch the heap, basically the table. But we cannot do that if the table is all bloated and you have a lot of dead rows. So yeah.
No, and I think that's one of the critical things that a lot of people miss. And I know eventually, running a vacuum process, when it started, was a manual process, and it was a very heavy process. It's not something that you can do just in the background without impacting the performance, because you're basically rearranging your sock drawers, if you will, right? You're rearranging how everything is set up, and that has an impact.
Yeah, there is. It actually got improved quite significantly now. So, the major difference, well, I guess we were talking about Autovacuum here. So the vacuum, as I said, is a garbage collection. So it comes and cleans up the table. And if you run a vacuum on a table, what it will do, it will traverse the whole table. It will get all the dead tuples. It will populate the area and memory. It will also rescan the indexes, and eventually you will get a table that has 0 dead rows, ideally. Not in every situation, but it's, it's awkward. It's like gathering statistics manually. Statistics are universal for each database, so I like the statistics analogy. Whether you're using MySQL or Oracle or PostgreSQL, you need fresh statistics for the table. Like it changes, you need to adjust. Maybe you have a data ski, right? So running manual vacuum is like running manual statistics stats collection, right? It might work, but you also may miss a point between the runs where the data changed significantly. So you can schedule a vacuum to run like every night at off hours. But in the middle of the day, you have a lot of transactions that update and generate a lot of dead rows. And what you get then is decreased performance for the rest of the day. And you will also get a larger table because in the end, because vacuum doesn't reorganize it, right?
But isn't it really a trade-off, though? So when you're talking about running vacuums more frequently, they can run faster, yes, but there is a performance impact. So at a certain point, it's almost like, is the performance impact of having a lot of dead rows greater than the performance impact of running a vacuum?
That's a great point. But yeah, I mean, before I go to that, so the good way to deal with the vacuum is to run the auto vacuum. And that's where I was going to. So instead of running vacuum scheduled, you run the auto vacuum. And the auto vacuum is a bit more intelligent. It's still not really intelligent, but it is intelligent enough. It doesn't work by time. You don't schedule it. It works by the activity. So if the certain amount of rows or a percentage point of the table changes, it will activate and it will process the table, right? And then we come to your question. What is the trade-off, right? So there are 2 kind of points where, on the spectrum. Well, the one where you don't run vacuum at all, and the one where you run vacuum, let's say, after every row is updated. And neither of that is good, because nothing is black and white, and we need to try to optimize for everything, right? So yeah, well, that's a valid point.
Yeah, and I mean, so the concept of auto vacuum, right, is that automatically running. But and this is where I see that there is debate, and I've seen people talk about some of the downsides of vacuuming too often, or frequently, because it does slow down your production. So I've seen people actually take and delay that as long as humanly possible, but then they run into other issues, because you can actually, there's some events that you'll actually run out of, certain, counters internally that can completely see. Sergey knows what I'm talking about. Completely seize up the system.
Yeah. But even before that, you will have significant, severe performance issues, because you will have to run the vacuum eventually. We will talk about the counters, right? The counters is one of the grave outcomes of not running vacuums. But when you run an auto vacuum or you run a regular vacuum, it needs to put two tuple row references into a memory area. And that memory area is unfortunately finite, right? So you control it. You can set the worker, it's not work mem, it's the maintenance work mem, right?
Mm-hmm.
And you can set it pretty high. You can set it to 2 gigabytes, 5 gigabytes. Unfortunately, it's allocated in full. So once you run a vacuum, you will get 5 gigabytes of memory eaten up. And here, the interesting thing is, if you have more dead rows that would fit into that memory area, and not rows, but the references, but anyways, you will have to repeat the operation of the vacuuming on the table. It will continue, because it would have actually processed the rows. But every time it does so, it has to rescan every index. And every vacuuming operation scans all the indexes. We talked with you a bit ago about indexes, right? And I said you probably don't want to have too many indexes. You probably don't want to have too many indexes, because your vacuum will have to read every single one of them in full, and probably many times, if you don't have enough memory. And so that memory usage is proportional to the amount of dead rows, not the size of the table, thankfully. And so what you get is, if you delay your vacuuming too far, you decide that I want to keep, I don't know, a billion dead rows there, it's fine. I have all the space I need. Maybe I use a cloud and the storage is auto-scaled and it's cheap, or maybe it's expensive, but I have the money. The problem is, once you run the vacuum, eventually, you will have to rescan every index desperately, and yeah, that will have an impact on the database, right? And that even before we come to the question of the visibility.
And I mean, so I think that the fear that I often hear is, with auto vacuum, you don't really control when it's going to kick off, so it can kick off at the worst time.
Yeah, it probably will. But
Sergey, thank you for saying.
Yes,
it will probably kill your. Probably.
It will kick off, because it will kick off at good times. It will kick off at bad times. It will kick off at all the times, right? Because if you have, I don't know, if you change million records every hour, and you tune your auto vacuum to run on tables when the million rows are changed, the auto vacuum will scan that table every hour. It doesn't know whether it's your busy hour or non-busy hour. The question is, if you postpone it enough, will that hard auto vacuum, like having to scan multiple indexes, will that be in your good hour or bad hour? So as you can probably guess by now, I'm pro auto vacuum. I like it to run. I like it to run frequently. Although there are situations, undoubtedly, I made a table that was really a megabyte size table. I allowed it to bloat to a gigabyte in size, because it's still funny numbers, right? Even though it's 1,000 times overhead and it had a lot of dead rows, I didn't care, because as soon as auto vacuum executed, it could process it in a few seconds, right? But what I see is, I don't know, 5 terabyte table, like that's a great example, but a few 100 gigabytes table, which is allowed to bloat, which is allowed to get 20% of its rows dead, right? 20% of the dead rows in a 500 gigabytes table is, well, a lot of rows. I can't do the math properly, not on camera at least, but it is really a lot of rows. And then when the Autovacuum will start, and the math is difficult because you can probably guess that at, I don't know, 1,000 TPS, if you run Autovacuum every change of 10,000 rows, it will run every 10 seconds or so. At 20%, it's difficult, and it will scale as the table grows, right?
But this is why there's two parameters for Autovacuum, right? So you've got the scale factor and the threshold. So I mean, that's really what that's designed for, right? Is to ensure that you can do either a percentage or an exact number.
They are summed, but if you set a ratio to 0 and the factor to 0, but the number to absolute value to a high number, like 1,000,000 rows, you will get a scan every 1,000,000 rows, right? And those are configurable by table, right? So you can actually go up and update every table. Like if you really want to get really into fine-tuning the Autovacuum, which I don't recommend because it rarely works, and you will forget about that, and it will wreak havoc for you eventually. But you can conceivably go ahead and fine-tune for each individual table in each database, right? So you can control the Autovacuum, but the greater point there is that Autovacuum actually, apart from it using up some resources in the system, as my colleague Jobin likes to say, Autovacuum is really gentle. So it is optimized. The Autovacuum process is optimized to be really light on the system, to do just enough job, to do just enough, to produce just enough load to process everything, right? So by default, it actually sleeps every 20 milliseconds. Doesn't sleep every 20 milliseconds, but it has a set amount of work it can do. And by default, I think it can process like 200 pages at most. Or 20 or 10 if it reads them from the disk. So not a lot of pages. And then it sleeps for 20 milliseconds. So yeah, right, it will have to read the data, but it will be doing it in a really paced way, really lightly, not like your, I don't know, update on a table that updates every row. So
yeah, and I think that's one of the things. Getting those tuned properly is so critically important, right? And and just to let everybody know, there is ways to fine tune individual tables, even, right?
Yes, yeah. So you can adjust the relation options. So every table in PostgreSQL has sort of a column called rel options. You can alter individual table properties. You can set scale factor. You can set when the rows there will be frozen. And yeah, you can do a lot of stuff. You can even disable Autovacuum for a table. Like if you really know what you are doing, you can just go ahead and disable Autovacuum on the table at all. That's probably never a good idea. At least I can't think of any conceivable, any reason to do so. But you can, right? You can disable Autovacuum, or you can disable Autovacuum everywhere and enable Autovacuum on a few tables.
Okay.
Although that probably won't work. Yeah, I can check. But at least you can override, you can disable Autovacuum. That's for sure.
So don't fear the Autovacuum.
That's my point. That is my point. The Autovacuum. I have two issues, kind of. The one issue I see is, again, the good. I think a good analogy is table stats. When we talk about stats collections, a lot of people think that automatic stats collections are bad because they skew the data and so on and so forth. And so the Autovacuum, it runs automatically, but it runs unpredictably, it runs at unpredictable times, it will produce unpredictable load, although that is not true because you can actually calculate the load, at least guess it. So I don't think that you should ever disable Autovacuum. And I want to get to the point that you were bringing up with the visibility of the rows, but other problem is running with the default settings right until every Autovacuum execution is so hard on the system that it is actually a problem, right? So the default settings in PostgreSQL, it's actually pretty common. I think it's universal for almost every setting of PostgreSQL. They are pretty good. You can survive for a long time with them, but they are not tuned by any means, and they are suitable for, I don't know, a small development instance maybe, like a QA environment maybe. But in production, at least in largish systems, you will, overgrow the parameters pretty quickly. And let's say the default value of 20% rows to be changed before the Autovacuum executes. That is quite a lot, right? So you will get a substantial amount of work to be done by the Autovacuum once it runs. So maybe if you have a single outstandingly large table, you should think about maybe overriding those on that table. If you have a lot of large tables, then you can probably think about changing the parameters on the global level, on the system level at all, right? So because as I said, the rereading of the indexes while the vacuum is running or Autovacuum is running, it happens proportionally to the amount of dead rows. So unless you have an infinite amount of memory and you can set, maintenance work mem to like terabytes of memory, you will eventually run out of that memory. You will have to rescan the indexes, and that is what is causing major grief, right? So, and also the auto vacuuming, it doesn't release the space because it cannot release the space in like the beginning of the table where you had few dead rows, and then there is a single row version, but the others are dead. You cannot give back to the operating system. Like it's just an empty page, half full. But maybe if that page changes later, it will be stored in the same block. But if that block was still filled in, it would have to allocate the other blocks. So by running Autovacuum more frequently, you combat bloat more efficiently. So, which is one of the, and I wanted to touch on what are like, what will we see actually if we disable Autovacuum, right, Matt? I think you started touching on that point. So, what do
Yes.
you hear?
Yeah. So, what happens when you disable Autovacuum? What do you run out of?
Bad things. You run out of space. You run out of space. You run out of performance, and you run out of the transaction counters, or actually the transaction counter visibility, the transaction visibility. Although the last thing is no more a thing. At least when I started working with PostgreSQL, the documentations, which are still available, they're archived, but they're still available. They had like huge disclaimers about running out of the XIDs, right? Because you could and people had corrupted their data. Because if we go back to the start of this, kind of meetup and me talking about the dead rows, I mentioned the transactions, they see the versions of the rows, they can see the dead rows, right? And the dead rows have an ID. Each row has an ID of the transaction that inserted it. And in PostgreSQL, each transaction sees 2 billion of transactions before and after it. Okay, I will do it like this. I have to to help myself a bit with fingers. So what happens if we go past the horizon? Suddenly, those transactions that were in the past and the rows that were in the past are now in the future, which is bad. We don't like time travel, at least not when it's databases, right? If we wrote something down, we want it to be, there, always visible, and never in the future, suddenly, like it never was there. And that is what will happen eventually. Thankfully, PostgreSQL will never allow that to happen. If it does happen, it's a bug, it's a serious issue, but really, it probably won't happen. PostgreSQL will shut down, it will prevent startup, it will make you run the manual vacuum to prevent that. But even long before that, it will actually run a special vacuum, a special aggressive vacuum to prevent wraparound that has a few properties compared to the regular auto vacuum. And even before that, Autovacuum will actually do the work necessary to prevent those bad things from happening, right? And in really simple terms, what that work that I mentioned is freezing the rows. So when the row is frozen, the ID of the transaction that inserted it is marked as always in the past. That's basically it. So that row that we processed is basically always visible for every transaction in the system, forever and ever, until we change it. So, and that is really, really, really important for PostgreSQL, although not for reasons that people usually think.
Yeah. No, makes sense. Now, by the way, I disagree with you. There are some times when I would like time traveling in my database, like, when I can go back and get like a bigger bank account, like, when I had money, like, last week or
Yeah,
something,
right.
like I'd love that. But I understand the concept and the concerns there. So, that's completely understandable. So, for those who are watching, feel free to just throw out questions or comments if there are things that you want to ask. It doesn't even need to be related to this topic. We like to kind of go down the rabbit hole of whatever is top of mind for those out in the community. So don't be shy. Feel free to ask the questions. Because if not, then I get to play my favorite game with Sergey, which is Stump the Expert. Oh, look. So as soon as I predicted Stump the Expert, and I was going to throw some interesting questions and let him look at some workload, we get a question. So let's go ahead and pop this up. So what's the question from Dinesh? I have a few tables of size, so a terabyte. When Autovacuum Wraparound gets executed, it takes several hours to complete. I think it takes a lock on the table too. Are there alternatives for this?
Right. So that is actually what I mentioned as a consequence for the database, which is from Autovacuum not executing. Like most people think when they think about Autovacuum, at least from my experience, they think about bloat. It goes like this: bloat, performance, and then wraparound, because it's really hard to get wraparound on PostgreSQL.
Yeah.
Like it's almost impossible. Even the developers discuss on the forums that triggering the wraparound condition is exceptionally difficult right now. So, but what happens here is the tables are really, really large, and I'm sorry, I don't know the settings, I don't know the setup, but I would guess that the settings are the default. And so for really large tables, the Autovacuum will trigger after a lot of rows are going to be changed. But the age of the tables that XID counters of the visibility of the rows, the age of the tables, which is what triggering the wraparound issues, it doesn't change when the table is updated. It's actually changed whenever a transaction executes, real transaction that changes data. And so you can have a table that doesn't really change, which will get old, and on which the wraparound protection vacuum will have to execute. And so, and that Autovacuum to prevent wraparound is not really an Autovacuum. It's like the Autovacuum's, evil cousin. It's like Waluigi or something. Because Autovacuum, Autovacuum is really nice. The Autovacuum is running, it's doing its thing, and you need a log on the table. You want to alter it or you want to do something. The Autovacuum will release logs, it will just die off. It will print a message in the error log if you configure it to do so. It will tell that it was aborted or canceled, right? But the wraparound vacuum, it's gonna execute until it's gonna execute, right? Even if you cancel it, you can go ahead and cancel it to remove the logs. The Autovacuum launcher will just launch it again. And that's actually a pretty efficient way to release the deadlocks, because what I see sometimes is people execute DDL on the table. And so to answer this particular question, I think it takes a lock on the table too. Right, it does. Every vacuum does take a lock on the table. And that lock prevents you not from issuing DML. You can still update the table, insert rows, but it will prevent you from executing DDL. And if you execute DDL, your regular Autovacuum will release the locks and die. The wraparound prevention Autovacuum will not release the locks. So you will have wraparound prevention vacuum, you will have a DDL, and then everything else that is behind the DDL waiting to get a lock will get stuck, because now you have a lock contention on the table. And so what you can do in this situation, just as an incident resolution, you can just go ahead and kill the wraparound vacuum. You will not lose any work, because as it goes, it updates what it does. So it will just get restarted. So what are the alternatives for the wraparound Autovacuum? The alternative is regular Autovacuum.
So is that more of adjusting your threshold and scale factor to
yes, exactly,
more frequently?
Yes, because again, the larger the table, the more rows have to change to trigger the Autovacuum because of the scale factor. Because you have that scale factor that plays into the number of rows. And I saw live systems in production, where some tables were never actually auto-vacuumed apart from this wraparound prevention vacuum, because the wraparound prevention vacuum or auto-vacuum, it launches after 200 million transactions have started in the database. And 200 million sounds like a lot, but if you have 1000 TPS, I think that's like a month. But basically, you by now you have so many TPSs in the databases are so loaded that you can run out of that 200 million counter pretty quickly. But the large tables might not have enough rows changed in that time, and they will see this. They will see the wraparound Autovacuum. So my suggestion is, do adjust the scale factor. Do try to adjust scale factor for these large tables, and make sure that Autovacuum is running on them and not the wraparound prevention vacuum. It is much better to have it.
The default's 20%, right? A scale factor of 20%?
Well, I think yes.
Which would mean that would be 200 gigs.
Well, it is not 100 gigs. It's 20% of the rows. So if you have 1 billion rows, you have to change.
Yeah, I was equating it to the. Yeah, you're right. You're right.
It's a bit different.
Think of it like that. Yes. Like if you've got a 1,000 gigabyte system, potentially, 20% of that. Yeah. And the follow-up question: does regular Autovacuum reduce the XID count?
Yes, it does. The RAS settings, the default is after 50 million rows transactions. Eventually, after talking about vacuum, you get, you have everything mixed up.
What's a few hundred million amongst friends?
Yeah. So after 50 million transactions are executed, basically after an age of the table is past 50 million, regular Autovacuum, when doing its work, will actually do the freezing for you. So it will pick the rows and it will freeze them actively. And after 150 million rows, it's going to be even more aggressive. So if you do have regular Autovacuum runs on your table, you will not see the wraparound protection vacuum happen. There are still cases when it will happen. There are some tables which will never be auto-vacuumed, right? And those tables are pretty special. And PostgreSQL has some improvements recently for those, but the tables that may never get auto-vacuumed and that may only ever have the wraparound protection vacuums are the read-only tables and the insert-only tables. Because we are talking about changing rows, but if you are only inserting data, nothing is changing. So Autovacuum will not trigger. However, like whatever scale you set, just know it won't happen. At least until PostgreSQL 13, which improved that. And now insert-only tables are getting Autovacuum specifically for that reason, and also to update the visibility map to make index-only scans work. But the read-only tables aren't. So one thing I noticed is that like you load a large table like from the dump, and you use it as you just run selects on it. But eventually, the wraparound protection vacuum will execute on that table. It might, be kind of hefty.
Okay.
So yeah, to answer the question, yes, it will.
Excellent. Thank you for the question, Dinesh. Appreciate you hanging out and asking. So thanks for that. Are there any other questions? Because if not, my phone's ringing. Oh, I got a slow Postgres database that I need Sergey's help with. Oh, we're going to look at a slow Postgres database, everybody. Sergey, are you ready?
Yes, I am.
Okay. So I am going to show you, PMM, and you get the call that the database is slow. Okay.
Okay.
And so I can either give you the URL if you want. I can send it to you, or I can just share my screen. We'll just do screen share for now. How's that sound?
Yeah, just share it. I think it's gonna be fine.
All right. So let me go ahead, and I'm going to get here, and dun dun dun. Here we go. And I can zoom in if it is too small for people. I always have a problem with getting the screen share just right so we can see what's there. But let me go ahead and I'll zoom in even a little bit. So let's see. So Sergey, my Postgres SQL server that's running right now is slow.
Alrighty then. So, great. I like PMM. Let's go to.
And by the way, Sergey did not know that I was going to do this, so this is totally off the cuff, and you can't hold them responsible for any of this.
This is all because you didn't ask me questions. You have
yes. If you would have asked more questions, you could have saved Sergey from a fate worse than death, which is looking at my PMM instance.
Alrighty then. So what I would like to do is I would like to go on and check your operating system node. So if you go to services, yeah.
So where am I going to go here? Like
to the system node. System node. It's a hosted database, right? It's not like RDS. I need node summary.
Node
overview. Node overview, right? You're always getting mixed those up.
You want the overview or the summary?
I want a summary.
Okay.
Show me your node. Show it to me. Show everything.
Show you the node. Let's see. So how do I? Let's see. Node name. The name is 162. No, that's the MySQL one. So let's see. Is this the one?
It does have PostgreSQL actually.
Yes, I think this one's the one. Hold on a second. Let me just double check. See, I should have prepared a little bit more here, but you know what? That's how I roll. You're getting the live, unadulterated. No, it's the 4 one. The live so this is my node here.
All right, and it's burning up.
Burning up. Look at that. Look at that. I'm gonna go to the last hour, and it is burning.
Okay, so a lot of context switches. So let's see what's happening. Is it all CPU? Can you scroll down? So I'm kind of
let me set this up a little bit. Okay, so we saw some issues that happened. You see, like, the context switches start to change, and the number of processes, changes as well. So anyways.
Yeah, so let's see what's up with the disk. I just want to understand where we are with regards to the CPU and the disk. So IO activity dropped. So you are CPU strained. So it's all CPU load that is causing this. So let us go to the PostgreSQL overview.
Okay, we'll go to the Postgres overview.
Actually, summary. No, overview is again the whole instances overview. So let's go to summary.
You're killing me.
Yes, I am.
All right. So let's see. That's
not
funny.
Making it easier for me because you are removing the annotations, which could say like I was doing that, I was doing this.
Yeah, because I added the annotations.
142 is kind of idle.
I
think it was 44.
Wait a minute. Was it 44? Sorry.
Yeah, I think it was.
I need to rename these so that this is better. All right. What's interesting is we should file a bug that we should maintain the service name across when you switch.
I think it does mostly, but maybe because we navigated to the overview, it got reset.
I don't know. That's a weird one. But anyways, okay, so here you go.
So let us see. You have fewer idle connections and you are reading a hell of a lot of tuples. So can you scroll down a bit for me?
Yes.
Read tuple activity is really, really high, but you don't have so many changes. And the transaction counters has dropped, which is maybe either because you have changed, you have a change in the workload, which switched from writing to reading, maybe. Or maybe because you are reading so much, your write transactions don't get enough love and they're just not pushing through as many rows as they could have, right? And the duration of the transactions is really, really high. So talking a bit about the vacuuming and the XID wraparound and the whole thing, the Autovacuum can only, or any vacuum, can only clean up dead rows that are invisible in the system. And by invisible, it means that no active transaction is able to see them. And it doesn't really matter if that active transaction would read them, database doesn't know. So if you have few hours long transactions, within those few hours, the rows that that transaction could see will never be vacuumed. So even if you run Autovacuum really diligently, but you have exceptionally really long queries or long transactions, which would make your database probably an OLAP, right? Or actually, what's worse, a hybrid with OLTP OLAP workload, then you have nasty issues with the Autovacuum, and PostgreSQL doesn't really cope very well with mixing those
So
up.
the longer the transactions here,
yeah,
the more difficult you're going to have.
Yeah, you will have more and more dead rows. You like, yeah, it's gonna happen. So the Autovacuum cannot process. So what we see here, well, I was just playing alone to our main theme, but yeah, the duration of transactions spiked from 10 seconds to like 15, 20, which is not okay. Like it's not nice. And you have idle transaction queries, which is also, which is like what I said. Those transactions haven't yet executed a commit. They're just, not allowing our database to work. You have a lot of temporary files being created, and the temporary file sizes is growing. So I would reckon that we need to take a look at your read activity. So let's scroll down a bit, and then we will go to QN. Okay, logs, row exclusives, no, access share log, movie JSON test. We even see the nicely here, we even see the hot table here, I would guess, because you have quite a lot of logs a bit above on the number of logs panel. You are, I think, you have access share log movie JSON test, and movie JSON test is either a database or a table. I don't really remember on top of my head, but so we have our probably hotspot in the database right there.
Okay.
So the buffers, checkpoints, fine. So I guess you actually will have a read workload right now. Checkpoint stats, written files to disk. So not
it's not checkpointing at all, or very
Yeah.
limited. I mean, it does.
Yeah, it's fine. Like it's every 5 minutes or so, as we would expect. So it was checkpointing quite heavily before. So by checkpointing, you can easily spot whether PostgreSQL is writing or not, right? What I said above, when we were looking at is I didn't know what happened with your write activity. Has it subsided on its own? Or maybe you pushed your instance a bit too far and your write activity suffered and it just dropped, right? By checkpoints, I would guess that it just stopped, right? So maybe it naturally decreased. So I would want to look at the queries running in your database. And for that, we have QN.
And I'll need to, so we're still selected at 44, so that's good.
Yes, because we didn't go to the overview.
Yes.
Yes, nice. So we even maintain the last hour overview, and we have those nice spark lines, and those spark lines never lie, and they show us a huge spike.
They never lie.
Yeah, they never do. You have a nasty spike in the load right about maybe 25 minutes ago, right? So if we go to the top row here, the top row is kind of not this one, the top row, the total one. Yes,
yeah.
it does have its own spark line, and it does have its own like query counts and query times and the load. What's more, load is like QN's way of saying load average. And yeah, you can click on the total. So if you want to see the global overview, that's what you do. And it does show us that the query load increased for some reason. And as we see, most of the load, at least right now, on your system is read-only. So something happened with your queries. And thankfully, you have a kind of skewed issue where the query number 1 is the one I want to look at because its spark line is really suspiciously close to the outline of the general load of the system, right? So I would imagine that this particular query is causing us grief. So I actually don't see like bottom half of your screen. So if you can scroll down a bit for me. Okay, so what do we have here? Row send 310. It's not a lot. And it runs at 40 milliseconds, but it runs really often, right? 133 QPS. Yeah, alrighty then. So not a large query, but apparently it's enough to push a lot of load. And the query count, the query time has actually changed, right? So you are actually sending fewer rows, but the query time has increased. So the spark lines are changing there.
Yes.
And the shared block doters is changing. So maybe schema changed, or maybe something else happened, but I don't know. So let us see examples, just so that I understand what kind of queries are we talking about.
No examples.
Sorry, no examples. Yeah, probably you have a schema there for the table, but yeah, let's see tables. All right, so what do we have here? What was the query again? I forgot how it read. Title equals 1. Guess what? You're missing an index, I think, don't you?
I'm missing an index. That's right. And you know what? You weren't the first one to spot that. So, you know,
Yeah.
we had that pop up here. So what do you think? Should we add that index?
Yes, we should. And actually, for this particular column, I would actually recommend that you create a hash index because,
Really?
yes, because titles are usually checked for equality, and like the text columns, especially longer text columns, right? They are rarely checked for something other than equality. So it's like, is gladiator greater or equals than matrix? You know, maybe by its rating, but definitely not by its name.
So
or maybe you could do a key comparison.
So is there a benefit though to create both a hash and a B tree?
Not on the same table, not on the same column. I wouldn't say so because, but there are some
because
columns.
There are some like comparisons, like where the title is like.
But, yeah, for those, right? But maybe the like comparisons, the if you are going to be using the title with some fuzzy search, like you are putting in not matrix but a3 or try just instead of the full name, you probably need an index suitable for the text, for the full text search. B3 will not help you. Like if you do like, you know that, but if you do like something %, you're not using an index anyway.
Well, but if you do have the beginning, it does work.
Well, yeah, for the beginning, right. So it really depends on how you are accessing. But if your question was whether you want to have 2 indexes, I would not recommend it, right? Yeah,
I was curious on your opinion.
Yeah, no, because Autovacuum would have to scan both of them, right? And we don't want that.
Oh, back to the Autovacuum.
Of course, keeping it on the topic. So yeah, if you always have an equality and you always know the title, for this particular case, a hash index would be great because it only works for equalities. If you are doing likes and stuff, either try regular B3, it will work to a certain extent, or go on to the genes and whatnot for the full text search. Although for a short column like this, it probably may or may not help.
So I added the index.
So, cool.
See the drop?
Yes.
See the drop, be the drop. There you go. Look at that. Sergey, you successfully navigated. You successfully did this test. So congratulations on finding the needle in the haystack and doing it in an efficient 10-minute way. See, this is how we roll. We never know what I'm going to throw out there. I have all these knobs and switches on these databases. So when we don't get a lot of questions, I start to throw some curveballs. And maybe next time I'll create that terabyte-sized table and see if we can get a wraparound issue.
Yeah, get a wraparound, lock a DDL behind it and see how it see how PitchBench suffers or something. Yeah, that's gonna be fun.
All right. Well, thank you, Sergey, for coming along. Hopefully everybody enjoyed this. This was informative. Feel free to, stop by the next one. Bring your questions. It doesn't have to be about the topic. We will go into details on anything that's Postgres related. And I think that's, something that's important for all of us to realize that this is your time, not just our time. We're here to try and, teach you something, educate you. If you did like this, go ahead and subscribe, hit the like button on YouTube or Twitch. That tells us that you want to see more stuff like this. And if you like me throwing some curveballs at some people and like giving them some tougher technical issues to dive into, let me know, and I'll try that next time. We should be back. We're off next week because in the U.S. it's Thanksgiving, so holidays here in the U.S. And then we're back the week after where we will be doing a PMM focused meetup with Michael Colburn. So for all of us here, thank you for showing up. Thank you for participating. We really enjoyed having you here. And Sergey, thanks for the overview on vacuuming and auto vacuuming. It was great.
Thank you for inviting me, Matt. And thank you everybody for watching. Looking forward to maybe some more of your riddles.
All right. Bye-bye.
Yeah, goodbye.